It is one of the oldest questions mankind has ever asked. Are we alone in the universe? With the universe as vast as ours, could it really be true that we are the only ones in it? Surely there was some other inhabited world out there. In the 19th century, the question became more specific. How common was life exactly? Could it be common enough to have arisen multiple times in our own solar system? Could it exist, say, on the planet the most similar to our own? Could there be life on Mars? Speculation raged. Sci-fi writers imagined entire alien civilizations on the red planet. Although this has calmed down in the last century, as our first probes and satellites went there and sent back photos of nothing but barren deserts, the question didn't entirely vanish. It simply reframed itself. Could life have once existed on Mars? Not now, but in the ancient past. And for all of our inquiring, to this day it is a question that only has one answer. Maybe. Thanks to probes that have gone on before, we know that liquid water once existed on Mars. And where there is liquid water, there is the possibility for life. This was an incredible discovery when it was made in the 1970s, but it is not proof. It's a question that, if it were proved positive, would forever alter our entire view of the whole universe. Because if life arose twice here, in our solar system, it almost certainly arose elsewhere. But until we find that first fossilized example of life on another planet, we will not know for sure. So NASA said, let's become sure. This is a video about the rover that went to go check. I'm Alex McColgan and you're watching Astrum. Join with me today in this supercut as we delve into the first campaign of the Perseverance rover, the NASA machine tasked with actually collecting samples of fossilized microbial life on Mars to return to us before the decade is out. This could be the rover that finally lays the ancient question of are we alone to rest. So, how did that first campaign go? Perseverance launched on the 30th of July 2020 on an Atlas V rocket. There was a great launch window around this time where Earth and Mars were aligned just right for a quick rendezvous. In fact, China and the UAE also launched a rover and probe respectively during this same launch window. The cruise took 7 months, and checks on the system showed that Perseverance was in good shape for the atmospheric entry. Landing is the most nerve-wracking part of the whole journey. The extremes in temperatures and speed involved make it very dangerous. NASA have had a lot of practice at it though, and seem to be getting better and better every time. NASA have this cool visualization on their website that I want to show you, because I want you to appreciate that landing a car-sized rover on another planet is no mean feat. First, about 4,000 kilometers from the landing site and traveling over 16,000 kilometers per hour, the cruise stage is detached, and thrusters are used to stop the craft from spinning. At an altitude of 120 kilometers, the craft has sped up to over 19,000 kilometers per hour, but it's here that the Martian atmosphere begins slowing Perseverance down. Due to turbulence in the atmosphere, thrusters are being used to keep the spacecraft steady and to keep this heat shield facing forward, as friction from the atmosphere is heating the shield up to over 1,300 degrees Celsius. Computers on board are autonomously monitoring its position, keeping it aimed at its final landing goal. At 60 kilometers up and 16 kilometers from the target, the atmosphere has slowed Perseverance down to 3,000 kilometers per hour. Now this is where things start to get interesting, as the spacecraft was fitted with a number of video cameras, giving us an unprecedented view of the landing sequence. First, the huge 21-meter parachute was deployed. You may notice the odd pattern in red and white. This is useful for scientists to see the orientation of the parachute, but there's also a hidden code in there. Dare mighty things, the NASA Jet Propulsion Laboratory's motto, written in binary code, with the GPS location of JPL on the outside. At 10 kilometers up, and having slowed to 600 kilometers per hour, the heat shield is released, reducing the weight, and exposing Perseverance to the Martian atmosphere for the first time. At around 4 kilometers up, the spacecraft begins imaging the surface to search for a safe place to land. At 2 kilometers up, once it's happy with the landing spot, the upper casing of the spacecraft separates, leaving just Perseverance and the rocket-propelled descent stage. Rockets are necessary as the parachute can't slow the fall anymore. Mars's atmosphere is simply too thin. The rocket stage slows the fall from 300 kilometers an hour to 0, and it hovers 20 meters above the surface. The rover itself is then lowered using cabling, suspended by what is known as the sky crane. And once it's safely on the ground, the rocket stage cuts loose to crash a safe distance away. How amazing is that? And actually being able to really see it is incredible. After a 7-month journey, Perseverance landed on the surface of Mars on the 18th of February 2021. Perseverance is NASA's most ambitious rover yet. To give you a sense of scale, the thing is massive. NASA have basically sent a car to Mars. You may notice though that its looks are heavily based on its famous predecessor, Curiosity. While it may appear almost identical, there have been some major improvements of the design based on what didn't work so well on Curiosity. One noticeable difference is the wheels. Curiosity's wheels have shown some serious wear so far. So Perseverance's wheels are thicker and more durable. They are also less wide, but have a larger diameter. Another improvement is its robotic arm, which is longer and stronger than the one on Curiosity. But the most notable differences are, unsurprisingly, the scientific instruments on board. Because while Curiosity was designed to investigate whether Mars was once a place conducive to life, Perseverance is looking for actual evidence of fossilized life. The first step for it will be to find compelling rocks, and it has an advanced suite of instruments to help it do just that. On the mast is a powerful camera called the Supercam, which uses a laser to identify the composition of rocks. The camera itself takes a photo to visually identify what the laser is pointing at, so it's not actually this camera that takes the impressive panoramas you'll see later. However, this instrument is really important. It can analyze a rock from several meters away, which means the rover itself doesn't need to move within arm's reach of a rock it wants to identify, allowing it to move on to a new region quicker. The 3D panorama cameras are also located in the mast, and they can zoom, focus, and take video. Once intriguing rocks have been identified with the cameras, Perseverance can move in closer and examine them with the spectrometers in its arm. There are 2 cameras in the arm. A normal color camera called Watson, and another laser camera which can also take microscopic images called Sherlock. Interestingly, I found these images in the raw files of the cameras, and upon investigation, it turns out they brought this along to test the cameras are focusing well, and that the laser reads the material correctly. There are various materials on the rover, including spacesuit fabric, and some with Sherlock Holmes Easter eggs. For example, this has a maze on it with a tiny Sherlock Holmes image in the middle, and this rock sample has 221B Baker written on it, the famous address in the books. Apparently, one of these rock cross-sections is actually from a suspected Mars meteorite. If true, it would be the first known instance of a rock from Mars doing a full round trip to Earth and back. Another of the instruments is basically a weather station, an instrument that will keep track of the wind, temperature, humidity, pressure, and dust levels. Towards the back of the rover, there is a ground-penetrating radar instrument, which will be used to see the geologic features under the surface. And there is also a rather special experiment module, MOXIE, that will be used to see if oxygen can be extracted from the Martian atmosphere, a crucial necessity for the survival of future human colonies, and surprisingly, even a way to produce rocket fuel. Leaving a planet's gravity naturally takes a lot of fuel. For Mars's lighter gravity, it still requires 30 to 40 metric tons of propellant. It's even harder to do on Earth, and becomes harder still if you have to also carry all the fuel you will need to make the trip home again. However, knowing that we might be able to make most or all of that fuel from liquid oxygen found on the planet makes space travel much more feasible. The last experiment on board relates to Perseverance's primary objective, finding compelling rocks that may host microbial fossils. Once the cameras and spectrometers have identified promising candidates, the arm is equipped with a drill that can either abrade the top layer of a rock to expose the unweathered surface beneath, or if the mission team wants to extract a sample from the rock, the drill can also core out a chunk. The arm will feed the sample through to the body of the rover, where a second arm will move the core to a place where it is sealed, and then a place where it gets stored in one of 20 caches that will be on board. Interestingly, although Perseverance was cleaned as much as possible before launch to avoid contaminating Mars and also these samples, even tiny traces of gases from the rover itself could skew readings. To combat this, there are also some witness tubes that are preloaded with witness materials that can capture molecular and particulate contaminants. Each witness tube will be opened on Mars to capture the ambient environment. They will then be sealed like the normal sample tubes. Comparing the witness tubes with the cached samples will allow scientists to know what the contaminants are and eliminate them. But sadly, Perseverance will not be able to confirm the existence of microbial life by itself. It is actually designed as a forerunner mission. Once Perseverance has filled all the caches, it will place them for another mission to pick up. NASA wants this to be a sample return mission. However, the means of collecting these samples has not been finalized yet. A launch is currently slated for 2026, using a rover to pick up the samples and deliver them back to a rocket, where this rocket will rendezvous with an orbiter, which will make the journey back to Earth with the samples in our hands come 2028. It's a very complicated system, so let's hope the mission teams will really get everything right in the coming years. As the rover turned on its cameras and took in its surroundings for the first time, it found itself staring out across the red, arid, and solitary landscape that we have come to expect from Mars. The terrain around it was mostly flat, albeit interspersed with rocky outcrops. This was intentional. Scientists had deliberately brought Perseverance to a place where its wheels could transport it freely, and where it could find sites of particular scientific interest. To that end, they had chosen Jezero crater. Thanks to the outcroppings of rock that surround the crater, Perseverance would be able to collect rock samples from many different geological periods without needing to do major drilling, helping scientists piece together the geological history of the Jezero crater and to get a better picture of the most likely locations to find life. It would spend some time investigating the sections of Jezero crater near its landing site in what is known as the Crater Floor Campaign, before moving on to the Jezero Delta as part of the Delta Front campaign. You would think that Perseverance would be on the move almost immediately, eager to begin its mission. Thanks to the outcroppings of rock that surround the crater, Perseverance would be able to collect rock samples from many different geological periods, giving it plenty of opportunity to get started on its search. However, you would be wrong. Despite landing on Mars in February, it wasn't until nearly 5 months later that Perseverance made any major effort to leave its landing site and begin its journey. And this was not just because scientists took time carefully testing every single piece of scientific equipment and its software to make sure everything was working smoothly. You see, Perseverance was not alone. In fact, it may surprise you to discover, but you might say it was because Perseverance was pregnant. Cradled in Perseverance's undercarriage, hidden by a dust shield from the Martian winds and atmosphere, Perseverance had brought with it a second, smaller passenger to Mars. And much of the initial few months of Perseverance's time was spent helping bring that second passenger into the world. This second passenger was to be Perseverance's companion for the journey ahead, as well as an interesting tech demo. This smaller robot was not a rover. Its name was Ingenuity, and it was the first ever attempt at a helicopter on Mars. After performing several tests on Perseverance's own software and hardware, scientists turned their attention to this smaller 1.8 kilogram drone. The atmosphere on Mars is about 100 times thinner than Earth's, making it uncertain whether a helicopter's spinning blades would even work there. it would be difficult to displace enough air to create lift. Ingenuity was incredibly lightweight to compensate for this, and its rotor could spin at revs of over 2,000 RPM. Its only scientific equipment was a camera, but this would be invaluable in helping Perseverance find the best routes through the potentially tricky Martian terrain. So, on the 21st of March, nearly a month after landing, the berthing began. Perseverance started by removing its dust shield, allowing Ingenuity to taste the Martian air. Mechanical berthing is a slow process, however, with scientists constantly checking every single piece of data to make sure everything is functioning as it should. It wasn't until the 3rd of April that Perseverance finally placed Ingenuity on the hard Martian soil and allowed it to experience its first cold night on Mars. Temperatures on Mars reached lows of minus 100 degrees Celsius, so outside of the protective heaters of Perseverance, it's no small thing that Ingenuity survived the night with no problems. But scientists were delighted that this part of the mission went smoothly. During this stage of Perseverance's mission, it looked on like a proud parent as Ingenuity began to take its first wobbling steps, although, just like a parent, Perseverance couldn't resist taking a selfie or two to show off to its friends on Earth. Ingenuity's first flights did not go completely without a hitch. After taking time to test its rotors at varying speeds, Ingenuity did run into some software issues that worried the engineers who'd worked on it. However, by the 19th of April, Perseverance was able to record as the solar-powered drone attempted the first ever controlled flight on another planet. The flight was done autonomously, as the time it would take for a signal to travel from Earth to Mars would create too much lag to try and fly remotely. And there were a lot of unknowns. Mars has a lighter gravity compared to us, as well as having thinner air, which meant that testing the rotor on Earth didn't necessarily mean it would work on Mars. It's hard to properly replicate lower gravity on Earth, for example. But fortunately, and with incredible smoothness, Ingenuity rose to an altitude of 3 meters and remained hovering there for 39.1 seconds, just as planned. Scientists were very excited when the tech demo that had been proposed just 6 years earlier had proved itself a success. Ingenuity was not expected to last long on Mars, but it kept going and going, flying further and higher than every previous attempt. It didn't crash, didn't break, and actually has become a useful scout for Perseverance, to find good routes for the rover to take, or to search for points of interest too small for satellites to detect. Ingenuity went from a disposable tech demo at the beginning of the mission to a valuable aid and accomplice for the Perseverance rover. What about Perseverance? The Martian rover was not completely idle during this time. Perseverance was able to test out a lot of its own gear while it waited for Ingenuity. Perseverance was equipped with a microphone, and scientists hoped to get the first ever audio sample from the Martian surface. Soon after landing on Mars, Perseverance was able to do just that, giving us our first idea of what the wind on Mars sounds like. It certainly adds to the desolate feel of the landscape. Perseverance also spent time driving short distances to test its motors, took panoramas of the surrounding landscape, and even successfully extracted oxygen from carbon dioxide out of the red planet's atmosphere using its MOXIE instrument. MOXIE, which stands for the Mars Oxygen In Situ Resource Utilization Experiment, managed to produce about 10 grams of oxygen in 1 hour. Which is not that much, but to be fair, MOXIE is only a prototype about the size of a car battery. It would need to be 100 times larger if we're to actually use it on the red planet to support human interests. However, just knowing that it works is an exciting step forward. But as fascinating as all these things are, there was one thing that Perseverance still needed to do. It had come here to discover one very important thing. Was there ever life on Mars? And so, during this period of downtime, scientists were busily plotting the best possible route for Perseverance to take. Although Perseverance's landing was one of the most accurate Mars landings NASA had achieved so far, it was still many days' travel from some of the 40-meter tall outcroppings of a rock at the edge of a crater known as South Sitar that scientists wanted to investigate. and between South Sitar and Perseverance's landing site, there lay a dangerous dune field filled with loose sand, impossible for the rover to cross without risking getting stuck forever, which would spell an end to the mission. Scientists would need to decide the best possible route around the dunes. Was it better to travel anti-clockwise around the crater, which would get Perseverance to the outcroppings faster? Or would it be better to travel clockwise, which would take longer, but would allow the rover to stop by more interesting rocks along the way? In the end, as is often the case in space exploration, it came down to efficiency. Scientists chose the second option, to allow it to do as much science as possible in as many areas as possible in the limited time the rover had available to it. Perseverance was finally given the go-ahead. And so, on the 1st of June, almost 5 months after arriving on the Red Planet, Perseverance's wheels trundled into life, and the rover finally left the safety of its landing site and set out on its primary mission, to collect core rock samples from locations life could potentially have flourished, for ultimate return for analysis to Earth. The search for alien life could now begin in earnest, with Ingenuity following along to keep Perseverance company, of course. Millions of years ago, a massive object had crashed into the surface of Mars. The resulting crater was hundreds of meters deep and 40 kilometers in diameter, and due to the different geological conditions that existed back then, it soon began to fill up with water. In time, this crater became a massive lake and earned the name Jezero, which, somewhat unimaginatively, literally means lake in some of the Slavic languages. Massive rivers began to run into the Jezero crater, carving valleys through the terrain and depositing all the resulting silt over huge deltas. This is why Jezero was selected as the site for Perseverance's mission. If life worked the same way here as it does on Earth, this location could be rife with possibilities for the emergence and propagation of life. As Mars is now a barren wasteland, the kinds of things Perseverance is looking for would not be immediately obvious. Any life that swam in Jezero's lake would have lived, died, and fallen to the lakebed, where accumulated silt from the river would have buried it in hard rock. Perseverance would need to make good use of all the tools at its disposal: its drill-mounted arm, its ultraviolet spectrometer Sherlock, and its X-ray fluorescence spectrometer Pixel to find this evidence. However, it is important to choose targets carefully. Perseverance has limited resources available to it. It only has just over 30 sample tubes for storing rock cores for the return journey home. Tempting as it might be to just grab a sample from right where it landed, Perseverance needed to only collect samples from the locations most likely to provide evidence of signs of life, or offer particular insight into the formation and age of Jezero crater to pinpoint better possible locations for later. As such, Perseverance did not start drilling immediately, but instead began traveling south from its landing location at Octavia E. Butler Landing, named after the science fiction author, to the area known as Cratered Floor Fractured Rough. Although this location was less than a mile away from Perseverance's landing site, Perseverance would not arrive at this new location for nearly 60 days. This is because the unfamiliar, rocky surface of Mars is strewn with obstacles for a rover. You'll notice the rocks that are scattered over the Martian surface. Perseverance would need to pick its path carefully around these, as the rover's 52.5 centimeter diameter wheels can only drive over objects that are so large. Soft terrain poses just as many dangers. The previous Martian rover Spirit came to an unfortunate end after getting stuck in a sand dune. So choosing its path is a balancing act, not too hard and rocky, but also not too soft. And in the past, these decisions would have been made on Earth with a 20-minute average signal delay. No wonder the previous rovers had travelled so slowly. However, Perseverance had gotten an upgrade compared to Spirit and Opportunity. Advanced AI software called AutoNav on the Perseverance rover allows it to map out its surrounding environment and choose for itself the best path through it. Although there is still some oversight from Earth, this greater degree of independence, which Perseverance can do on the fly while driving, allows the Perseverance rover to travel much faster than the rovers before it, allowing for more science to get done. And speaking of science, on the 20th of July, Perseverance successfully managed to navigate its way to cratered floor fractured rough. Taking things slowly, scientists picked out a rock to first test Perseverance's abrading drill systems. The abrade attempt took place on a paving stone nicknamed Guillaume, and it was a simple success. The drill cut away the top and gave scientists insight into the kind of stones that Perseverance was driving on. By examining grain sizes, chemical composition, and other details, scientists would gain insights into the type of rocks these were, either sedimentary, the kind likely to contain fossilized remains and other artifacts, or igneous rock formed from magma. What they saw heartened them, and on the 6th of August, scientists picked out another target rock, nicknamed Rubion, to take their first actual core sample. Due to the time zones involved, it was only 2 AM Pacific Daylight Time when over 90 engineers and scientists gathered online to witness the fruits of their years of labor. Perseverance cored successfully down to the 7cm depth it had been programmed to reach. It photographed the hole afterwards, and everything seemed to be going fine. Over the next 6 hours, Perseverance painstakingly took the core, placed it in one of its tubes, and moved it to its adaptive caching assembly, the place where core samples are processed. Due to the nature of the mission, it's vitally important that no contaminants be allowed to enter the tube, or else it might invalidate the entire process. Finally, Perseverance transferred the now sealed tube to its storage unit. Scientists were elated at this perfect first-time success. But then more data came through, and scientists realized that there was a problem. The sealed tube was empty. Confusion filled them. Where had the sample gone? Due to the limits of technology, scientists could not record on camera every movement of Perseverance. It only has so many cameras. So they had to rely on Perseverance to follow the orders they sent it. But here it seemed that Perseverance had followed its orders, and yet the weight sensors in the storage unit informed them that the tube was missing any additional weight. The core was gone. Perseverance drove backwards and looked between its tracks, but there was no sign of a dropped core. In time, scientists arrived at a bittersweet conclusion. Perseverance had not malfunctioned or done anything wrong. It was the rock itself that was to blame. In the act of drilling, the unique nature of the Rubion rock meant that it was so crumbly that when Perseverance had gone to pick the core sample up, it had completely turned to dust. Perseverance could not collect it in that state. Scientists had tested Perseverance's coring on 100 different types of rock on Earth, and it had never encountered a problem like this before. Every other rock had been cored successfully. So while this was good, because it meant that Perseverance was not broken, it cast a shadow over the rest of the mission. Would all the rocks Perseverance encounters be failures like this? However, NASA was not about to give up without trying. They reasoned that the rocks in this area were likely particularly weathered, and other rocks on Mars might hold themselves together better. It was with renewed determination that Perseverance had another go. Casting its camera around, Perseverance spotted some rocks 150 meters away that were as different from the crumbly paving stones as possible. Scientists nicknamed these new rocks Citadel, which is French for castle, possibly hoping for something a bit more fortified this time. As these rocks were sticking up from the landscape, it seemed reasonable that they were made from sturdier stuff than the flat paving stones. If they resisted erosion, they might do a better job of holding themselves together under a drill. Perseverance trundled over to the ridge and primed itself for another attempt. On the 1st of September, NASA once again held its breath as Perseverance attempted its second core attempt. You really get a sense of how painstaking this process is, given the month-long gap between each attempt. Everything on Earth has to be checked and double-checked, every scrap of data analyzed for the perfect conditions. Every decision is carefully thought out and discussed. Would it work on the second attempt? Perseverance's drill collected a core that was 6 centimeters long, and, possibly with wry exasperation, before sealing the core in a tube, Perseverance brought it round and added an additional step. It took a photo of what it held to confirm to everyone on Earth that it was actually holding a core this time. Scientists must have felt a huge relief as data came back that Perseverance had successfully taken the core and transferred it to its storage area. The core, nicknamed Mont Denier, was ready to be taken back to Earth on a future mission where, in a larger lab, its secrets could be better analysed. Perseverance took another core sample that day, just to be absolutely certain. They were possibly feeling on a bit of a roll, and who could blame them? They were now one step closer to knowing whether life ever existed on Mars. Although this sample was just the beginning, and may not have any signs of life in it, they had stepped a little further into the uncharted. A week or so went by. A first success was swiftly followed by a third and a fourth, both taken from the rock named Rochette in early September. The crater floor campaign was going well. At that point, sadly, it had to take a pause for solar conjunction. Due to the arrangement of our solar system, Mars and Earth do not always have a line of sight on each other. Sometimes they are on opposite sides of the solar system. This increases the lag time it takes for NASA to send and receive messages from Perseverance, but that is not the worst problem. When Mars and Earth are perfectly opposite each other, communication between the planets becomes completely impossible for one simple reason: the Sun. No radio signal can penetrate this cosmological giant. As such, there was little scientists could do but wait for these orbital bodies to move apart. Perseverance has advanced AI on board, but it still needs to check in with NASA from time to time to plan its route, update its mission, and report back its findings. So it wasn't until November 2021 that things could really get going again. But NASA was not idle during this solar conjunction. By the time Perseverance was powered up again, the NASA scientists had already thoroughly worked out its next objective. In Jezero crater, there is a dune field known as Citar. In amongst these dunes, there is a series of outcroppings that were of particular interest to Perseverance's mission, due to the many different layers of exposed rock they gave access to. These different layers likely represented different geological eras, which would give scientists the clearest picture of the history of Jezero, as well as giving them an opportunity to find life itself. Outcroppings are of particular interest because Perseverance's drilling equipment only allows it to dig several centimeters deep. If it wasn't for outcroppings, where erosion had exposed these layers to the Martian atmosphere, Perseverance would not have access to them. However, sand dunes are of particular danger to a rover like Perseverance. With help an entire solar system away, if Perseverance was to start wheel spinning in a section of particularly loose dune, it would likely spell the end of its mission. As such, Perseverance's trusty sidekick Ingenuity was sent in to conduct some preliminary reconnaissance. If it could find a route through the sand dunes that looked safe, Perseverance could get its sample tubes to the vital outcroppings of Citar. Ingenuity began its scouting before the solar conjunction and flew for several flights from September through to December. Flying at a height of 10 meters, these reconnaissance expeditions allowed scientists to pick out the perfect route. Perseverance set off in early November 2021, beginning its exploration of the dunes. It picked its way carefully, being sure not to travel too fast in case it fell into any unforeseen sand trap. It moved between dunes that were a meter high, finding the flattest path. But thankfully, Ingenuity had led it true. Perseverance was able to make it to the protruding rock known as Brack. Now that it had its technique down, Perseverance quickly was able to obtain new samples. Deciding to call the first empty sample container at Brack an atmosphere sample, these next two samples were officially Perseverance's 5th and 6th sample tubes and their 3rd and 4th rock samples. From these accumulated samples, scientists were able to make an unexpected discovery. These were not sedimentary rocks, as had first been anticipated. Instead, Perseverance had discovered the igneous rock, olivine. Olivine is a type of mineral that can actually be found here on Earth, for instance in parts of Australia. Unlike sedimentary rocks, which are made by particles of sand and other detritus slowly accumulating on top of each other over time, an igneous rock like olivine is formed by the cooling of magma. As such, it seems that at one time or another, Jezero crater must have been witness to some volcanic activity. While this might initially seem to be bad news, you might correctly conclude that not much life could be found in magma. Scientists could discern signs of water erosion on the rocks. The ridges at the ends of the crater showed signs of water motion. Whatever volcanic activity had happened here, the water that created Jezero's delta must have come after it had already cooled. As such, the presence of igneous rocks was actually good news. Igneous rock is usually very high in minerals. This is why the areas around volcanoes are so fertile. The presence of water and high mineral count rocks could have been the perfect conditions for life. All in all, Perseverance's mission seemed to be going well. But Mars was not done with it. The desert does not give up its prey quite so easily. On Wednesday the 29th of December, on the return journey out of Saitar, Perseverance stopped to take another sample from another rock outcropping known as Isol, specifically from a small stone known as Rubion. Initially things seemed to go well. Perseverance cored its target rock with no issue. It placed its core in a test tube. But when it came to transferring the test tube into the bit carousel on the rover chassis, it hit an unexpected resistance. Something was blocking the tube from entering the carousel. Perseverance immediately stopped its process when it detected the anomaly and sent a request to NASA asking what it should do next. Through week-long exchanges, NASA was able to use Perseverance's cameras to peer inside the carousel. Staring back at them were 4 small pebbles. Now, this might not seem like a big deal, but pebbles that stop samples from being stored inside the rover would put a halt to Perseverance's entire sample collection mission. It was likely that these rocks had somehow fallen out of the tube during that specific sample collection, possibly once again because of the unexpectedly crumbly nature of Martian rocks. Rocks falling apart had already cost Perseverance 1 sample. Now they might spell the end of the whole mission. But the Perseverance team had a plan for situations like this, and carefully the rover began to enact it. Firstly, Perseverance started by taking photos of the ground below it. It wanted to see what was there already, so that once the pebbles were spilled out onto the floor, scientists could count the new arrivals and make sure that they matched up with what had previously been seen inside the carousel. Secondly, it did something it had never been designed to do. It emptied out its core sample tube onto the floor. It must have been with regret that this was done. However, it was important to know how much was left inside the tube to see how much was likely in the carousel. Also, this would allow a fresh Isol sample to be taken later, maximizing its sample space efficiency. Thirdly, Perseverance began to do the only thing remaining it could do. It started to wiggle. By rotating its carousel, it was able to dislodge 2 of the 4 offending pebbles right then and there. By double-checking the floor afterwards, scientists were able to detect both pebbles, now no longer along for the ride. But this still left 2 pebbles remaining, and these were proving to be stubborn, not falling out with the carousel's rotation. So, Perseverance took things up a notch. It began driving away, searching for a spot where the slope was steeper. The plan was to position Perseverance at an angle, leaning forward so that gravity could start to pull on the last 2 pebbles. Its sturdy base meant that this could be done with relative safety, although tipping over would have been a disaster, so scientists would be careful not to pick a place that was too steep. A suitable location was just a short 5 meters away. Perseverance drove there and arrived at its location only to make a surprising discovery. The other 2 rocks had vanished. Initially cautious and then elated, the NASA team deduced that the rumbling of Perseverance across the Saitar sands had caused the rocks to shift and then fall out. They made sure to carefully test their equipment, making sure that the tubes could be correctly docked again. And only once everything was proven to be functional did they claim success. Perseverance was ready to go again. This may seem like a short drama, but my telling of the story might have been misleading. It was the 29th of December that Perseverance first picked up these stowaways. It was only on the 27th of January 2022, an entire month later, that the rocks were completely confirmed to be gone. This is because when you've spent millions of dollars getting a piece of hardware to another planet, care is always the watchword of the day. Although it sometimes takes weeks to plot out how to overcome a challenge, it's usually worth it for the longevity of the mission. Thanks to some careful decision making and moving correctly across the desert, Perseverance's mission could now continue. Having successfully collected its samples and overcome yet another challenge, it made its way out from among the sands. With Saitar Sands behind Perseverance, Perseverance's crater floor campaign was coming to a close. It would finally be time for the delta itself. If life ever existed in the now dry waters of Jezero, it was most likely the proof of it lay in those ancient river deposits, which was why it was time for Perseverance to really start booking it. The sands of Saitar had forced Perseverance to travel with care, picking its route carefully to avoid getting trapped in any loose sand. However, the terrain outside Saitar is much smoother. This allowed Perseverance to unleash its full potential. As it travelled up and around the outside of the dunes of Saitar, Perseverance proved itself by setting the land speed record for a rover on Mars, 319.8 meters travelled in a single day. Admittedly, that does not sound very fast. The distance is only about the length of 3 football pitches, but this is impressive for a Mars rover. This was roughly 50% further in one day than the previous record of 220 meters set by the Opportunity rover in 2005. And bear in mind, it did all this by itself, choosing its route with its autonomous AI system, AutoNav. Being able to assess the terrain around it, on the fly and by itself, the fact it could pick out the best route to avoid obstacles and rough patches is incredible. And given that Perseverance's top speed is believed to be 120 meters per hour, Perseverance still has a lot of reserves to tap into. And Perseverance was not done there. It also completed the first multi-day drive on Mars, managing to keep driving without any input from Earth over a 3-day period. This has always proved challenging for rovers. Usually, human intervention is required, and regular updates are needed to help negate the uncertainty that always creeps into a rover's awareness of where it is. Without this intervention, it may get lost, possibly leading into dangerous areas. But Perseverance's AutoNav was able to circumvent this issue. Although some uncertainty does still creep in, Perseverance is able to keep track of its own location well enough that it can be left to run without these regular updates, potentially meaning it can be left to run over weekends or holidays without any supervision from Earth. This allows it to travel much faster and further, getting to the places where the best science can happen. Not that Perseverance wasn't doing science along the way to the Delta, it just did some of it autonomously too. Oh, and I think it's time we talked about Perseverance's heat ray, which it can use, you guessed it, autonomously. Yes, Perseverance has a heat ray, which it can decide for itself when to deploy. I've mentioned this laser earlier when I spoke about Perseverance's supercam. What I did not mention was that this laser didn't just point to interesting targets, it vaporizes them. When I first heard about this, I began to suspect that whoever designed Perseverance had read War of the Worlds and wanted to circumvent any possible invasion of Earth by getting the first hit in. And while this isn't likely the case, Perseverance's laser is no joke. It can heat rocks to a temperature of 10,000 degrees Celsius, melting them to plasma and vaporizing them. Before you ask, this incredible tool is designed for use in evaluating the chemical composition of rocks, not vaporizing aliens. By heating rocks up to such a temperature, the light they start to emit can be evaluated to see which chemical markers it carries. Different elements and compounds release light at different wavelengths. by seeing what light a rock emits or doesn't emit when superheated can be key in identifying its chemical composition for some on-site scientific analysis. Also, it should be noted that this is done on a very, very tiny scale. On the 11th of March 2022, Perseverance zapped one fascinatingly purple-colored rock a total of 150 times in the same spot, vaporizing its outer layers to see what lay behind the surface. However, all these repeated vaporizations only bored a hole into the rock that was a single millimeter deep, hardly a weapon for fighting Martians. But these are the tools Perseverance employs as it continues its journey, working with scientists along the way to abrade and laser various samples for a little en route science. It even accidentally picked up a pet rock along the way in one of its wheels. This small stone was deemed not to hinder the rover's movements in any way, so scientists have left it be. So far, the rock has accompanied Perseverance over a distance of 8.5 kilometers over the course of 4 months, and has proved to be far less of a danger to its mission than the last rocks that it accidentally acquired. But with the arrival of one friend, another would begin to depart. Technology, although impressive, is not infallible. On the 3rd of May 2022, as Perseverance was reaching the end of its journey towards Yezero's Delta, communications dropped out with Ingenuity. The Ingenuity helicopter had accompanied Perseverance since the beginning of its journey, the two machines traveling together to the Red Planet and helping each other perform their different missions. Ingenuity had already amazed the world by being the first flying machine on Mars. It had scouted out the route for Perseverance during most of its mission, spotting hazards in advance so Perseverance could avoid them. But Ingenuity's intended lifespan of 30 days was already long past. Every day the helicopter still functioned was a gift, and one that could not keep giving forever. When Ingenuity first started off on its routine flight, Perseverance thought nothing of it. The two machines weren't always in line of sight with each other, instead keeping contact with frequent radio check-ins. However, when the next scheduled call should have come along, Ingenuity failed to check in. Perseverance froze in its tracks. Scientists thought desperately about what might have happened to the small helicopter. They theorized that if some kind of fault had occurred on Ingenuity, it was possible that it had gone into a safe, low-powered mode to preserve itself, thus missing its communications window, or possibly desyncing its onboard clock from Perseverance's. As such, Perseverance waited a full day, listening all the while to see if Ingenuity would wake up and start communications again. And thankfully, it did. The little helicopter was alright, reporting no major faults. However, its silence had been extremely worrying. It turned out that the problem was the levels of dust in Mars's air. Over time, Ingenuity's solar panels that kept its battery topped up had received less and less sunlight, causing the batteries to dip dangerously low. It had entered safety mode to keep itself from losing the heaters that kept it from freezing to death in the cold Martian nights. Ingenuity was given several days of lessened work to give its batteries more time to charge up to operational levels. However, this came at a cost. It would use its heaters less from here on. Instead of turning its heaters on when temperatures reach -15 degrees Celsius, Ingenuity would only turn them on at -40 degrees Celsius. And nights on Mars were about to get colder. Eventually, that cold will prove to be too much. Wearily, Perseverance and Ingenuity continued on, but now their goal was in sight. The sands of the Jezero crater floor were behind them. They had finally entered the Delta. With that, a whole new campaign would begin. Perseverance had done so much in the first year and a half of its time on Mars. It had performed science, traveled through dunes, and overcome challenges through careful problem solving. But did it already succeed in finding life? Ultimately, we will only truly know for sure when those samples return to Earth. Once that happens, it will hopefully be clear how influential the crater floor campaign has been. Even if it finds nothing, that in itself will hint at an answer. But for me, it's much more tantalizing to imagine that even now, the irrefutable answer to whether life once flourished on Mars might lie in a little transparent cache safely nestled inside Perseverance's casing. It might be in the next decade we find out that answer, but until then, Perseverance will remain true to its namesake and will keep on going with its mission. Thanks for watching this far. Want another rover story? Why not check out the amazing Opportunity rover mission recap here. A big thanks to my patrons and members. If you want your name added to this list, or simply want to support the channel because you like what I'm doing, check the links below. All the best, and see you next time.